Okay, today's session is on process management. Okay, so at the time of introduction, I told you what OS will do is it will manage all the resources. Okay, it will manage memory, it will manage process, it will what on managing side that it will do everything. Okay, so here our topic is today's topic is process management. Okay, so first of all, what is a process is process is nothing but it is a set of instructions which executes in the memory. Set of instructions nothing but programs. So the programs which are executed by the CPU that are in actively in the memory means RAM. Okay, so often you will confuse with memory with storage is nothing but hard disk is data in the hard disk is comes under storage. Memory is nothing but RAM. Okay, so it is created in the memory when a program or command is executed. So when a program is executed or program or command is nothing but some it is a program like program. Okay, so if when a program is executed, when a command is executed in Linux, a process will be created in the memory. So in Linux, every process is identified by a unique number that is known as PID, process ID, PID. So every process is identified by that number only. Okay, so if you want to see which process is running, you can easily identify that by using PID. Okay, so there are many processes that will start at the time of booting. Okay, which are running under the background. Those are called daemons. Already I have given some introduction about these daemons. So daemons are nothing but those are the background processes. They run on the background of your Linux. Okay, they are nothing to do with on the interact. Okay, so I will give complete information about the background information. So SSHD. So to run a SSH service, you must start this SHD daemon. Okay, in the same way there are a lot of daemons are nothing but background processes. These many of these background processes that will run at the time of booting. Okay, so the Linux kernel will communicate with the process by the process ID only. Linux kernel will identify every process by its PID only. So you don't know whether it is SSH service or it is HTTP service. Okay, so kernel only understand the process by its PID only, process ID only. Okay, so if you want to tell something about the process to the kernel, if you want to kill the process, if you want to change the priority of the process, if you want to manage that process, so you need to tell the kernel by its process ID only, then only it will understand. Okay, so daemon is nothing but it is a process that is running in the background. Sometimes in some Linux distros it is called services also. These are handled by system and process. Okay, these are handled by system and by the system and process that are handled by the users. Okay, sorry, uh, the the daemons are handled by the system. That means system on the background, these daemons are handled by the system and the process are handled by the user. Of course we can change that these daemons, we can change whether if you want to stop it, we can manage that daemons by users. Users can manage that one. But in general these uh, background processor handled by system. Okay, and general processor, the foreground processor, those are handled by users. Okay, so daemons are also called services like SSHD, Apache service, that is HTTPD. Okay, like that, crond, like that. Okay, so in RHEL 6 the first process is initd. At the time of booting I told you that initd is the very first process in RHEL 6 version. Okay, it starts at the time of boot time. So initd is the first process that is started by the kernel. Okay, so the process ID for the initd is 1. So in RHEL 7 instead of initd we are having systemd. Okay, it also starts at the boot time. Okay, and the process id for this initd in RHEL 6 and systemd in RHEL 7 is 1. Okay, so initd and initd in 6 systemd in 7 are the parent process for all the processes, parent process. Okay, this initd starts the remaining all other processes. That's why initd is called parent process. The processes that are started by the initd are called child process. Okay, child process, parent and child process. I will give information about that one in the next slides. Okay, so to manage or to see the information about the processes, that can be seen in two ways in Linux. One way is ps command and second way is by using top command. So if you use ps command, it is just like a snapshot of current status of the process. It gives only one terminal info, not about all the terminal info. So if you open one terminal, if you execute ps command, just it will give the processes at the time only. Okay, when when you execute ps time, at that instant, snapshot means that at that time of that current status only it will give. Okay, and also it gives the information about that terminal only, and it doesn't give the information about all other terminals. Okay, if you use top command, it will monitor the process continuously. By default, every 3 seconds it will refresh the data. That means we can see the live processes, data of live process with 3 minutes refreshing rate. Okay, whereas ps that doesn't it will give the snapshot only. Snapshot means when at that time only it gives the status of a particular time. So suppose if you execute ps at this instant, it will give the status of the process at that time only. Okay, next there are three types of process running in the, we can classify three types of processes in Linux. So first one is interactive process, second one is system process or daemon, third one is automatic or batch process. So interactive process are nothing but these are invoked by users and can interact with the user. That means up to now you have practiced many of the major comes under major process comes under this category. Interactive means, interactive means interacting with the system. The user will interact with the system by executing a command. That system will give the reply to that command. Just if you consider the command as a query, and system will give the reply to that command. So that is the interactive mode. Okay, so example for that one is vi. Okay, almost all commands, almost many of the commands comes under this category. Okay, many of the process comes under this category. vi is a example of that one. Vi, cat, okay, all those comes under. Okay, again this interactive process comes in the two categories: foreground and background process. Foreground process means is the process that you currently interacting with and using the terminal as its std in. Std means standard input, std out means standard output. That means when you are executing that command, when you are currently interacting with the command, at that time only it will take the input as well as it will give the output. Suppose if you execute some ls command. Okay, so at that instant only it will give that output on your screen means it is your terminal. Okay, so terminal means that is a display. So the display is known as standard output, std out. Okay, okay, so when you are typing with the keyboard, if you enter something, that is called standard input. Okay, stdin. The user interact using stdin, and that will display, that will give the output as std out. Okay, std out. So that is called foreground process. That means foreground process means everything simple. In simple, you can see that process on the foreground. That means the output of that process on the foreground. Whereas background process is not interacting with the user and can be in any one of the two states, paused or running. Okay. So it will that background process will run in the background, but that will run, or we can pause it. So how to send a command to the background is simply by executing by adding some ampersand size. Okay, we can send it to background. That means, suppose if ls command, if you enter if you execute ls command, that will give the output on the foreground. If you don't want to see that command on the foreground, if you want to send it to background, simply ls space give that ampersand symbol. Ampersand means and symbol. Okay, so that it will go to the background. So when you will do this type of this, suppose if you want to copy a large file, in such case you if you use that then that will be useful. Okay, so suppose if you want to copy a command, or suppose if you want to install a patch, in that time if you execute a m update command, or if you execute some scp command, a copy command, then if it takes some minutes of time, waiting for that is somewhat uh, somewhat we cannot wait now. It will be boring, or it will be something like that. Okay, so in that case if you want to send it background, you can use and symbol. Okay, and also you can use a no hop command. Okay, we'll see that those two commands. Okay, so interact processor, we can interact the system in two ways, foreground as well as background process. Okay, background we can send it background by using ampersand size. So you can do it pause command or running command. Okay, you can by using control z and control c, you can do that. Okay, whenever if you use control c, it will automatically terminate that process. Okay, we can manage that by using control z and control c. Okay, another type of process is daemon. Just now I have told about this thing, a system process or daemon. Daemon is a term used to refer the process that are running on the computer and provide the services but do not interact with the console. Okay, nothing the daemon is nothing but it is a service that will automatically that will run background on the background of your system. So but we can manage it only. Okay, we can start or restart it only, Daemons. Okay, but we cannot change that behavior of that thing. Okay, most servers are implemented using a daemon. That means if you want to configure Apache server, httpd is the daemon for that one. If you want to if httpd running, then only Apache will work. Samba, for Samba, smb, nmb there are two domains are there. If those two daemons are running, then only Samba will work. Otherwise, while configuring, we will start that one. Okay, like that we will have a lot of daemons. For ssh, it is sshd. For cron job, if you want to run cron job, cron d is the daemon for that one. For nfs, there are 5 daemons you need to work with. So if they run, then only nfs will work. Like that any process can become daemon as long as it run in background. So simply it is a simple thing, a simple definition. Any process can become a daemon when it run in the background, and also one more thing is it doesn't interact with the user. Okay, that's a thing about daemon. Okay, next one is next type of process, third type is automatic process. So these are never connected to a terminal, so there is nothing to do with this terminal. Okay, these are the tasks that are queued into a spooler area where they wait to execute on a first in first out base, FIFO based. So the example for this process is cron jobs. Okay, cron jobs and AT jobs. Okay, so these automatic processes are also called batch processes. These are scheduled tasks, scheduled process. Okay, by using cron or cron job AT. Okay, so if you want to execute at certain date and time, you use AT. If you want to do it repetitively, then you use repetitively, or system load. When the system load is low, if you want to do that, use cron job. Okay, but it is a scheduled at certain time you will do that one. Okay, okay, so if the system load is low, then at the time cron job will be used. If you want to do at only one certain rate of time, AT jobs will do. Suppose taking backup using cron job, okay, comes under this type of process. Okay, you know about cron job. Okay, already. So those are the three types of process: interactive, uh, system process, and automatic process. Okay, next. So generally there are two processes we can classify in. Okay, the process which starts or creates another process is called parent process. Okay, already I told you initd is the parent process of all the processes. It is the first process that is executed by the terminal. The process id for initd is 1. In RHEL 6 version it is called initd, whereas in RHEL 7 it is system d. Okay, those are the parent process for all the process. Okay, example for this example for the parent process is initd. Of course any process that start another process is known as parent process. Okay, and the parent process is identified by ppid. So every process is identified by pid, but a parent process of a child process is identified by ppid. Ppid is nothing but parent process id. Okay, next, in the same manner, a child process, if a process starts another process, that process is called parent process. The started process is called child process. Okay, so a process which started or created by another parent process is called child process. It is identified by pid. So child process is identified by pid, parent process is identified by ppid. Okay, that's it. We will see this the later. Okay, so we will execute some commands one by one. Okay, so already I told you to monitor or to manage the processes in Linux. We can do that by using these two utilities, ps and top. Of course you can have some more utilities. These are the basic utilities, ps and top. Okay, so the ps command, if you just execute this ps command, this will gives the running process of the present terminal and present command. The syntax for ps command is ps. Okay, and simple ps, and you will get come with some options are there. I will give some of the options. If you want to know more options about that one, you can use man command or help. Okay, to see the total number of process running in the system, okay, you can use ps hyphen a. Okay, so if you want to see the processes that are executed by a user, logged in user, then you can do that by using ps hyphen u. Suppose the username is yogi, by that way you can use. If you don't mention that username, then that will give the default logged in users. Okay, by default it will give the logged in users, present logged in users. If you want to know about other logged in users, you will mention like that, but you must be logged in as a root user. To see which processor attached to which terminal, terminals. Okay, for that you need to use ps hyphen x command. Okay, I will show you everything. Okay, ps-a is it will give the information about all the terminals. ps-aux means it will display all the terminals process information including background process also. Okay, suppose in that information if you get some arrow mark, then that is a background process. Okay, it indicates that background process. I will show you. In the same way, ps-a displays the total process information with process id. If you want to see the process id and parent process id also, then you need to use ps-. Okay, if you want to see the PID of a particular process only, then you can use this command PID of that process. Suppose if you want to see initd, then you can use PID. Okay, if you want to see the parent process, child process, all the structure in a tree format, then you use PS tree. Okay, next, if you want to see the particular process whether it is running or not, you can use like this ps-ux grep that process name. Okay, if you know the process id, then also you can see that. Okay, we'll see one by one. Okay, these are simple things, not that much, just you need to observe it. Okay, okay, so at present I'm root user. I'm on terminal. There are two terminals running. One is pts 0, second one is pts 1. Okay, now, okay, so if you execute ps, just ps. Okay, so there are only present command. Okay, bash is running, my shell is bash is running on pts, and I have not executed any commands. And it look here, it is showing ps also. Ps is also a process. Okay, it is showing ps also. Okay, if you want to see about all the terminals, okay, look here, this is the first terminal. pts0 is the first terminal. On the terminal, these are all, these are running, all these processes are running, su bash, all these. Okay, pts/1 is the second terminal. On this, ps command is running. So this is second terminal. Okay, my terminal may be this one. Okay, just if you want to know about terminal, which terminal I'm running, just tty. Okay, so I'm on this terminal. Okay, I'm just running only ps terminal. Okay, these are only foreground process it is showing. Okay, so if you want to see more, ps hyphen aux. Okay, look here, ps hyphen ax. Okay, yeah, not required. Okay, so look here, these are all total enter information. PID, look here, sbin initd. I told you now, initd is the first process. Init is the first process that is executed by kernel. So the PID is this one. Okay, so if it is shown like this, question mark like this, then it is running on the background. That's why if I execute ps just ps or ps hyphen a, it was not shown. It was shown just the foreground process only. Okay, these are all, these processes are running in the background only. So look here. Okay, and also all these are s, status of this one is s means sleeping. Okay, these are not active. Okay, so all these so every, you can see these are the PIDs, process IDs, sorry, PID and percentage of CPU, how much percentage each process is taking from the CPU. Okay, CPU and memory, how much memory they are utilizing. Okay, so init is taking 0.1. Okay, all these are different terminals. I'm sorry, it is question mark is showing tty na terminal, on which terminal it is running on the background. That's why it is not showing any terminal. Okay, so look here, all these processes that are running. Okay, bin bash cron d. Okay, ps-ax. Okay, and also look here, it is on terminal 01. On the other terminal also it is giving the information. It is pts0 is on the this terminal. On this terminal, pts this, look here, tty, this is another terminal. This is my pts1 terminal. Okay, so on pts terminals, bin bash and ax ps-ax is running. Present command also it is giving. Okay, so if it is background process, it doesn't give any terminal information. If it is a foreground process, it will give the that terminal. Okay, terminal information. So on pts0, these are the commands running. Okay, on the present terminal, my present terminal, it is pts1 and bin bash, these are running. Okay, if it is given question mark, that is background process. Okay, next okay, like that you can see all those. Okay, so if you want to see that with parent process, then you execute ps-ef, ps-ef, ps-ef. Okay, just difference between that ps-ax and ps-ef. You can see this ps-ax here. Look here, PID along with ppid. Okay, you know what is ppid? Ppid is the parent process ID, PID is the process ID. Okay, PID is the ID of this process sbin init, and ppid is the parent, its parent. Of course, init is the first process executed. Of course, there is no parent process for init ID, so that's why it is not giving. Okay, next, if you see this process, its PID is 3 and the parent process for this one is 2. 2 means this process 2, kth state. Okay, like that you can see. Okay, so look here, audit D. So for that the process ID is 1240 and 1 is the parent ID. Okay, like that. This here hold runner na. For that the process ID is 1448 and its parent ID is 1447. Parent ID it is hold D is like that. Okay, those are some of the examples. Okay, next if you want to see process ID of a particular process name, PID of that process, but if you want to execute that one you must know the process name also. So here we are familiar with initd na, init process. So if you want to see it, PID of init process, so that is one. Or look here, PSCF na, present running na. So PSCF command, the okay, so I will do some other thing, bin bash. Okay, it is giving any multiple number because this bin bash is running on different PDS. Okay, that's why it is different users and different terminals. That's why it is giving these number of bin bash. Okay, bin bash is a shell for all the users now. There are almost 4 to 5 users along with the root user. That's why it is giving all this. Okay, like that can do that. Okay, next anyways, ps3 is to display the parent child process in structure format. Okay, do that. Sorry, ps3, look here, if you execute ps3 that will give the tree structure of all the processes along with its child process, parent process with this init. Look here, init is the one which starts all the processes. Look here. Okay, HTTPD like that, all these are comes from init. Again they are having their child process. So for this gconf hyphen alpha, the parent process, this one, for this one the parent process is initd. Okay, that is like a tree structure. Okay, like that you can see the information of all the process in Linux. Okay, next, that practice well about this one. Next topic about on this process management is if you want to manage this process, if you want to modify the state of the process, how to do that. Modify means, suppose if you want to stop a process, if you want to reload that process, how to do that. Okay, so that can be done in Linux by using signals. Okay, signals are the way of sending, you know, general definition for signals is way of sending messages, signal. Okay, so in Linux the kernel will send signals, means way of sending simple messages to the processes. Suppose if you want to reload a process, you will send some signal to it. If you want to kill a process, you need to send some signal to it. Okay, some message to the process, then it will kill, the kernel will kill that process. Okay, like that. So most of these messages are already defined, those are already there are some signals already in that so the signals can only process it when the process is in user mode. Okay, next, every signal has a unique signal name. Okay, so there are almost 64 signals in Linux. So every signal has some unique signal name. Okay, like for killing, for stopping or terminating, everyone has some. I will show you now. E signal name is a macro, that means which stands for, it is a positive integer for every signal, because you know, kernel or OS whatever may hardware understand only binary means that is a numbers only, digits only. Okay, every hardware, digital hardware understand numbers only, even though we are typing commands or everything that, but a hardware at the end, the hardware understand only numbers only. Here also the in signals also given some numbers, those are called some macros. Okay, so if every signal has some unique number, that is a positive integer. Okay, signals can be generated by the process itself. Okay, they can be sent from one process to another process. Okay, there are almost 64 signals in Linux. Okay, so if you want to see it, you can use by using kill-l command, you can see it. Okay, by using kill command we can stop or terminate the process. Okay, this kill command is dangerous in real time. You need to execute very carefully while using this one. So if you want to list all the signals in Linux, you can do that by using kill-l command. So almost 64, there are total 64 signals in Linux. After those, these are some of the popular ones. Okay, most commonly used are 1, 9, 15, 20. So if it is one signal, one is reloading process. If you want to reload a process, you can use I1. If you want to kill a process, 9. If you want to terminate a process, 15. If you want to stop a process, 20, like that. Okay, so we'll see. Uh, kill -l. Okay, look here, sig hub. Every signal has some unique name: sig hub, sig int, sig bit, like that. Okay, we are having 64 signals. Okay, do some exercise on those signals. What is terminating, what is stopping, what is killing. Okay, for the next session, what is meant by stopping, what is meant by killing, what is meant by stop. Okay, so if you want to kill a process, simple thing to kill process, you need to send the kill signal. How to send that signal is, so first find the process id of that okay, process id of that process. So if you want to kill a particular signal, so simply use this command kill hyphen some signal number. So suppose 9 is 9 means kill that command. Okay, if you want to terminate it, give 15. If you want to stop that, 20. If you want to reload it, 1, give 1. Okay, kill hyphen 9 and that process id. Okay, so if you want to restart it, you can do that by using fg1. Okay, I'm not doing any practice session for that. Okay, next so in the same way, if you can kill a process by using signals, in the same way we can manage the process priority in Linux. Okay, we can then process priority means, the kernel is executing lot of process now, the CPU is executing some processes. So you can change the priority of each process. Some process will have high priority, some process will have low priority. That means priority means high priority means it will execute earlier that the preference is given to that process first, later the preference is given to the low priority tasks. Okay, so in Linux there are some guidelines for CPU to follow when it is looking at all tasks it has to do. That guidelines are called niceness or nice value. Okay, so the priority can be monitored by using this nice value, niceness. It is also called niceness or nice value. Okay, so this nice again, this is a integer scale. It is on the, sorry, it is on the some number scale. That niceness in Linux scale is ranges from -20 to 19. Okay, if you want to change the priority of some process, okay, to send some signal to the CPU, okay, you can follow this niceness guidelines. So the niceness values are from -20 to 19. The lower the number, the more the priority that task gets. Okay, if the number is lesser, then the nice number is lesser, then the task is high priority. The task has high priority. If the niceness value is high number like 19, that that has having low priority. Okay, CPU will process it when it gets a chance. Okay, low priority will process when it gets a chance, but it will execute the high priority. Okay, the default niceness value is 0. Okay, there are two processes we can change that nice value. One way is nice by using nice command. Second way is renice command. By using nice or renice, you can change the nice value of a process. So nice when before starting a process, you can use nice command. After starting, if you want to change the nice value, you need to use renice command. Suppose for example, um, uh, if you want to change the process priority of a process, okay, the syntax is like this. Before starting only, look here, before starting a process, if you want to change the priority, okay, then you can do that. Nice hyphen n means a nice range, okay, and 5, I'm giving the priority to 5, and my process is cat, okay, this kt file, I'm creating a file. So before doing that, I'm giving the nice priority to that one, okay, and check that priority of that process after starting, okay. Okay, so we will execute this one. So after starting, if you again you want to change that one, you can use renice command, okay. Now we will do that one. So my command is nice hyphen n. So I want to give the priority to some 5 or 3, okay. So before that, I'm not starting that cat command now, so it doesn't have any process id, okay, at that time. So now I want to give some process id like this, cat, and I'm creating a file, okay, for that command, okay, some file xx, okay. So its nice value will change. So it is changing. So if you want to observe it on this terminal, it is not possible. So I'm going with another terminal. So this is my second terminal. I will observe that from my first terminal. So by using ps-elf, you can see that. Look here, cat, the cat command, nice value 5, it was changed, okay. Nice ni means here look here, ni means nice value, okay. All by default, all the processes are having nice values like this, okay, but some of them are having priority was given like this, -4, -2, like that, okay. By default, the process nice value is 0, okay. So these are set by system only, okay. Now I set the nice value as 5 to this cat command, okay. This was done on I have observed on this second terminal, but nice value was changed here only, okay. Again I moved to my old terminal, okay. Next, to reschedule that nice value, if you want to, again I want to change the priority of that existing process, okay. Already it was running process, okay. So I want to change that PID. How to do that one is renice. By using renice command, you can do that. So how to execute that command is renice to process ID. Why you need to give this process ID means already it is executing. That process is already running. So you can give that process ID. So by using ps-elf command, you can do that, okay. On this ps-elf, okay. Of course you can use grep if you don't want to see everything, okay. Here cat is not running now, so I want to execute the command cat some file xx. It's running because I didn't given any command now. I want to change its priority. Now I want to change its priority. Renice and okay, and the process id is must. So before doing that, check the process id, ps hyphen elf process id of cat command. Okay, here look here, the process id is this one. The second one is parent process id 3934. So run that command, renice hyphen, I want to change the process priority to 3 and process id. Okay, new priority is 3. Okay, now check it.